Well, welcome back once again. We're in the news conference here right now, but despite that, we're going to go to this lesson, small sample t-distribution. This presentation is 7.5, and we're looking at the t-distribution here. And we want to look at small sample inferences when sigma is unknown and your sample size is small. We're going to examine a claim made by a tobacco manufacturer that the tar content of his cigarettes is significantly below 6.0 milligram per cigarette. We're going to test this claim. We take a sample of n equal to 18 cigarettes from the population, and we find the sample data is over here. The mean is 5.88 and so on. It's X bar and S, and we're saying that's all we know. We're going to look at a confidence interval estimate. When sigma is unknown and sample sizes are small, we use our sample standard deviation as an estimate of sigma. But in doing so, we create a bit of uncertainty, and we're going to be looking at a t-distribution with n-1 degrees of freedom, and we're going to suggest that whereas in the blue here, which is a normal distribution, the student t is in the red. And so when we use your sample standard deviation S as an estimate of sigma, the standard error is more uncertain, and as a result, we have to resort to not a Z critical value here, 1.96, but a student t value of 2.11 to account for the fact there's more uncertainty here. Now that value 2.11 comes from this t-distribution table. On the left side we have 17 degrees of freedom. When we go over to the right, under the column which represents the area in the right tail of this distribution. So for 95% confidence, two tails is 5%, one tail is 0.025. So coming down that column, we find this value 2.11, and that becomes our critical value. So now, whereas in the normal distribution we use these formulations here, the student t we use the 2.11, which is called the t-values. And this gives rise to a confidence interval of, coming on the screen here, as you see on the screen. And this interval represents a 95% confidence interval for the true population mean, mu. And we're suggesting that since 6.00 is in this interval, this suggests that the evidence is not sufficient to say that the claim is in error. Now we're going to look at another example. A sample of 21 people from a large office area. The mean systolic blood pressure 128.8, standard deviation 8.4. And we're suggesting that for a 99% confidence interval, the Z score is 2.575, but for the student t it's 2.845. It's a larger number that accounts for a certain degree of uncertainty. Now for 21 degrees of freedom, and 99%, which represents a 0.0051 tail, the critical value there is, as you can see on the screen here, and the confidence interval becomes your estimate plus or minus your 99% margin of error, which involves that t value. You see it coming on the screen here. This gives rise to this confidence interval. 95% chance this interval will capture the true population mean. And that's the end of presentation 7.5. We ask you to take notes, and when you're ready, go to presentation 7.6.